about chain reaction and as well as nuclear fission. The nuclear fission process is happened in a nuclear reactor. Means the control chain process means the nuclear reactor is a device which is works on a principle of a controlled chain reaction. In case of chain reaction, we have discussed about that when the uranium is bombarded with the slow moving neutron, that uranium emits 3 fast moving neutrons. When the 3 fast moving neutrons is in and the continuous process then bombarded with the another uranium atom nucleus, and that can be produced more neutrons, that will be the chain reaction. In that case of the chain reaction can be depends on the its multiplication factor, neutron multiplication factor K. Means if the K value is less than 1, means the number of the ratio of number of neutrons in present generation to the number of neutrons in the previous generation which is less than 1, then that process that chain reaction can be stopped is called as a subcritical state, as we know that. And the further if the number of neutrons in present generation to the number of neutrons in previous generation both are same, then the multiplication factor, the neutron multiplication factor K is equal to 1, that will be the, that is a chain reaction in steady state that can be controlled, that can be controlled is called as a that critical state. For example, nuclear reactor. In that nuclear reactor is working on the principle of a controlled chain reaction, means the chain reaction which is happened in the reactor can be controlled, so that here we can say that the nuclear reactor works on a principle of a controlled chain reaction. This is the labeled diagram of a nuclear reactor. The mainly parts we will discuss about it. In this case of mainly parts, the first one is fuel, nuclear reactor fuel. Reactor fuel means a fissionable material contained in the aluminum cylinders are called fuel. When the radioactive element of fissionable material which is participate in the fission process that emits the means uranium, if in case of uranium which has taken uranium 235 is in process in perform the fissionable process, then it emits the 3 fast moving neutrons. So the another one is next one is moderators. The moderators means which is the new fast moving neutrons are emitted by the fissionable process. Those speed of that fast moving neutrons can be reduced, we slow down the neutrons by using the moderators. These moderators are mostly made up of with heavy water or graphite, and all the fissionable material, all the neutrons not emitted at a certain time, some of the delay neutrons also there. For the delay neutrons, if the excess neutrons are produced in the fissionable process that to participate in the chain reaction, that chain reaction can be moved into the uncontrolled whenever the excess number of neutrons are emitted. So to control that one, the control rods which is used to absorb the neutron materials, excess neutrons which is emitted in the fission process, that is delay neutrons that is absorbed by the controlled rods which is made up of with boron. By absorbing that excess neutrons, the total reactor fissionable chain reaction can be controlled by the control rods. Even if the nuclear process is fissionable process is moving vigorously, then the total chain reaction can be stopped abruptly by using the control rods also. This is the function of, this is about control rods, and the which is the wall protecting this total chamber is called as a reflector. This reflector which reflects the neutrons which is emitted from this moderators or whatever the fissionable material fission process, the neutrons are which is emitted, fast moving neutrons moved into the chambers, then it will protect and reflect into the towards the moderators or control rods. So this is the reflector, mostly reflector made up with constructed with graphite. And the next one is radioactive shielding. This radioactive shielding is construct with the shield, steel, lead and concrete walls which is protect or absorbs or reduce the intensity of radiation which is emitted in the nuclear in fissionable process. So that is the function of radiation shielding. And whenever the fissionable process is going on, some of the heat is developed in the nuclear reactor. So that reactor heat energy is absorbed by the coolant which is placed in the besides the nuclear these moderators and control rods. That coolant will take into the water chamber to transfer the heat to the water. By the water is absorbs the heat which is brought by the coolant and it is moved moved to the steam. That steam is connected to the turbines to produce the electricity. And whenever absorbed the heat from whenever the coolant is moving from the water chamber, the heat is absorbed and the remaining cooled coolant are coming to the same process to continue the further process. So this is about coolant. Then what is the working of a nuclear reactor? How it all works? Let's see. The first one, when the fissionable material contained by the aluminum cylinders which is participate, which whenever the slow moving neutrons are bombarded with the uranium, then it emits the 3 fast moving neutrons. Those 3 fast moving neutrons move towards the moderators and moderators will slow down the speed of a neutrons. Whenever they slow down the speed of a neutrons, then that process can be fission process can be goes on further by that slow down neutrons will participate in the another fission process and they will emit another 3 neutrons, fast moving neutrons, and that moderators will slow down their velocity also, their speed also, and the total neutrons cannot emitted at the same time. Some of the neutrons will emitted after some time. So that delayed, that those neutrons are called as a delayed neutrons. Due to the delayed neutrons, the chain reaction can be increases vigorously, so that the delayed neutrons can be observed by the control rods to control the total reactor, to control the chain reaction. And also if the fissionable process is increases vigorously, the emission of emission of neutrons will go vigorously, then the total controlled chain reaction can be stopped abruptly by using the control rods also. So that whenever this process is going on, the heat energy is developed, so that the heat can be transferred by using the absorbing by the coolant and it is moved into the water chamber, and the heat can be exchanged between the water and coolant. So that way water absorbs the total heat from the coolant and becomes steam. That steam is connected to the turbines to rotate the turbines to produce the electricity, and the cooled coolant will move into the same chambers, and with some of the neutrons are escaped from this process that can be reflected by the reflector, and the radiation which is produced in the reactor can be reduced or absorbed by the protective shielding which is around to the nuclear reactor. This is about working of a nuclear reactor. Then mainly parts we will discuss how to write in the examination. For the examination purpose, let's see how do we write. Here if you write like this, you can get the good marks for that. So that the principle, first of all we should write that after drawing the diagram, then we should write that first principle. A nuclear reactor works on a principle of a controlled chain reaction. You should definitely mention that the principle contains 1 mark. So that's why if nuclear reactor works on a principle of controlled chain reaction. So that the mainly components of nuclear components are these one. The fuel, in the case of fuel, the fissionable material used in a reactor is called as a reactor fuel, that is uranium-235 or uranium-233. Both are the fissionable materials which is used in the aluminum cylinders for the fissionable process. And the second one is the moderators. A substance which slow down the fast moving neutrons is called moderators. Means which is the neutrons are emitted from the fission process from the fuel, then that can be fast moving neutrons can be slowed down by using the moderators. Moderators are made up of with mostly heavy water and graphite. And the next one is control rods. Control rods, we know that control rods are made up of with boron. made up of with boron. So here the boron rods or control rods is control rods are made up of with boron to absorb the excess neutrons or neutron absorbing materials, which the excess neutrons are which is emitted after the fission process that to sustain to control the total fissionable process, that excess neutrons can be absorbed by the control rods. Those are called as the control rods are made up of with boron. The next one is radiation shielding. The steel, lead and concrete walls are provided around the reactor to absorb and reduce the intensity of radiation is called radiation shielding. Radiation shielding. The next one is coolant. Coolant means the liquid which is used around the total parts that whenever the heat is producing due to the in the process of fission, the heat is produced, so reduce that heat, that coolant will absorb the heat. The coolant, the liquid used to remove heat generated by reactor is called coolant, which is the heat generated by the reactor during the fission process. That heat is removed by the coolant. So what is the working? Means uranium fuel rods are placed in the aluminum cylinders. Beside that, the graphite moderator is placed in between the fuel cylinders. In between the fuel cylinders, the control rods are kept in the holes of the graphite block, which is the having the in the graphite block, the control rods are placing like this. Then when few uranium-235 nuclei undergo fission, fast moving neutrons are liberated. Whenever the neutrons are liberated, these neutrons pass through a graphite moderator and lose their energy and participate in a further fission process. So that the heat generated is used for heating the coolant and transfer to water, steam is produced. So that steam is used to run the turbine to produce the electricity. This is about a nuclear reactor.